To the space station, ready for the event.
Eastern Kentucky University, this is Mission Control Houston. Please call station for a voice check.
Station.
This is the International Space Station. How do you read?
Station, this is Jana Zaid at Eastern Kentucky University. How do you read?
Read you loud and clear. How do you read me?
Yes, we hear you. Station, this is Jana Zaid at Eastern Kentucky University. How do you read me?
Read you loud and clear. How do you read me? Good afternoon.
Good afternoon. Welcome to EKU. We have the first question for you.
What is it like to work with astronauts and cosmonauts from other countries on research and development of projects on the ISS?
I would say that is the best part of spaceflight, or the people we get to work with. We've in training, we travel all around the world, Japan, Canada, over to Germany, other places in Europe, Russia, and it is absolutely wonderful. It really draws everyone together. It's a true international endeavor.
I know that astronauts have to go through so much training before going into space. So was there anything that happened that you weren't prepared for in your training?
And I think you said, is there anything we look, anything special about our training? Is that right?
Yes.
The training to fly into space, you're right. It took 2.5 years of training to get here to the space station, besides riding on a rocket. Learning how to do that, learning how to do the science. We had to learn how to speak Russian. And all of that has been useful up here. But I'll tell you, once you're here, you're in an isolated place, and you have to use your wits quite a bit. There's a fair amount of things we have to do here that we can never anticipate, that no one can anticipate in training. And so we have to just go by our wits. I'd say, 30, sometimes on some days, 50% of the time.
How do the astronauts communicate with each other aboard the International Space Station?
Well, we have a comm system here on board the space station. Usually we're just talking to each other like you and I are. If some astronaut is around the corner or a little bit farther away, there's fan noise here, so it's a little bit hard to hear each other. So we have an intercom system we can talk to each other on as well. But it's always nice to float over to one side of the station or the other and talk to our colleagues face to face.
Can the 55-foot robotic arm on the ISS lift more weight in space than on Earth?
And I'm sorry, I didn't understand the question.
Can the 55-foot long robotic arm on the ISS lift more weight in space than on Earth?
I believe you said, do things look different from space than from satellites? And the Earth is actually quite an amazing place to look at. The brilliant blue of the ocean. Usually we look down and we see the ocean. Usually we see clouds. And every now and then we get to cross over the Earth and see, we're always looking for cities, looking for places where humans are because we love to see that. Looking for volcanoes, that sort of thing. But it's always breathtaking every time we look out of the window.
If you had a choice to feel like you were always in microgravity, whether you were on Earth or not, would you choose microgravity?
That is a great question. I've thought about that a lot. And you know what? I think I would pick gravity, hard as it is to believe, because it is delightful. It's a lot of fun to have things floating right in front of you, to be able to fly from module to module. But there's something about us that likes to just be able to set something down and have it stay there, like a coffee in a cup would be nice to put on a table. But for right now, I'm enjoying microgravity as much as I can because it is absolutely delightful.
What do astronauts do if they get sick or injured in space?
So, well, I'm a medical doctor, and we'd like to have a medical doctor up here sometimes. That is one way to become an astronaut. But we have medical kits here. We can take care of most minor injuries, first aid, and I would probably be the one to do that. However, if I'm the one that gets sick, there is always at least one other person trained to be a crew medical officer, and we don't always have a doctor on board. We have specialists on the ground we could talk to. We have an ultrasound machine, so we could do some diagnostic imaging, take a look inside the body with ultrasound if we needed to, and a lot of experts to help us out. And if it got really, really bad, we always have our Soyuz to get home with. It's sort of our ambulance.
What experiments are you working on currently that you think will have the greatest impact on my generation?
You know, that's the great thing about science, is that you never really know. We are doing some basic science up here. It's impossible to say how that's going to help us in the future. We might be able to cure osteoporosis. We might be able to cure heart disease from some of the experiments we're doing here. Some of the more direct impact is going to be the way we do things. We solve very hard problems to fly in space. That's what space flight's all about, doing things that are very hard to do. And when you bring medical care to astronauts, it allows you to bring medical care to people all around the world that normally don't have access to nice hospitals. And that's at the top of my list because I'm a medical doctor.
What can you tell us about the Medaka fish experiment that is going on at the space station, and is it providing any helpful information for the osteoporosis research?
The Medaka fish experiment was one of the basic science experiments that were going on here. It was just finishing up when I arrived. So it certainly could lead to breakthroughs. You know, they were looking at individual cells, and that's why they were using the Medaka fish, so they could actually look at the cells that break down bone and that build it back up again. So who knows, when you're actually able to study this on the cellular level, rather than just measuring bone density in humans, who knows what we'll be able to find out.
Do large-scale weather systems look different from the International Space Station than they do on satellite images?
The view from the space station, it is quite a bit different from satellites. And the reason why I say that, satellites are a great capability. But what humans can do is look down and evaluate immediately the view that they're getting. They can look off to all sides. If they see something interesting in one place, they can look somewhere else. We've been able to study, say, lightning patterns, for instance, and there's no way you could have a satellite looking around and doing an evaluation, doing the brain work that a human can do. So in that sense, things look quite a bit different to humans, and I think it's very useful to have humans looking down.
Do you see evidence of climate change from space?
No, I can't. We're up here for 6 months, so there's not enough time really to see any changes. I'm going to be up here long enough to see the seasons. We can see glaciers up here. We can see icebergs, but we can't take any measurements up here per se. Now, I did fly 3 years ago, and I on the space shuttle, and I can't say that I remember seeing any differences that I could say were due to any long-term changes in climate change up here.
Given the current state of the economies of both the United States and Russia, given the current state of the economies of both the United States and Russia, what benefits could be expected from the findings from the space station that would make money spent on the space station worth it?
Well, at every level, I believe that it's worth it. Just to be a spacefaring nation, like I mentioned, to solve incredibly hard problems to get people in space. The technology that's required to do this and to do it safely makes everybody better, makes the industrial base better, because the precision has to be so much higher. And the great thing about spaceflight is it inspires people. When I became an astronaut, I probably knew 1,000 people in my life that wanted to be an astronaut and wanted to work for NASA, that went into some of the STEM fields, such as you might be going into. They may not have become astronauts. Most of them did not. However, they went on to doing great things in their field, in their technical field that they fell in love with. So I believe that besides all of the research findings and all the technology development findings, I believe that's one of the greatest contributions to our country.
Do you believe that technology developed on the ISS for life support could be applied to the environmental problems here on Earth?
That's a great question, because you know what? We have a water system up here that is completely enclosed. We can generate, and our atmosphere, we can generate our own oxygen, we can generate our own water. We take what we put out and turn it back into something we can take in safely. And yes, it's a very difficult thing to do, but already that technology is being used in some drought-threatened areas around the world. And I believe the technology will be able to be used quite a bit more, and to make areas of the Earth habitable that currently aren't habitable.
When you were working on new experimental ideas, how often is the result something new and useful that wasn't part of the original purpose?
That's the wonderful thing about science. It happens about 100% of the time. Especially in space flight, we cannot create this environment for any length of time for more than about 30, 40 seconds anywhere else other than on the space station. So every day is exploration, every day is discoveries. And I would say every single time we do something unexpected happens.
Out of all the skills you have obtained in training, which has assisted you the most in your adventures, and how do you use these specific skills?
You know, I would say training for working in space starts at your age or even before. Learning how to learn. And it's not so much exactly what you're studying right now, but if you're really good at what you do and try to do the best as you can, then you're learning how to get good at something. And so whenever you're faced with something new on the space station, which happens, many times a day, you can learn from it. You can even get better. And that is one of the skills I think that's very important to develop early, and certainly the most useful one that I found here on the space station.
After the next question.
On the NASA website, it said that NASA is planning on sending humans deeper into space than ever before. Would you be willing to become one of the first humans to travel that far into space with all the health problems associated with long-duration space travel?
Well, spaceflight is risky, but it's a calculated risk, as we call it. And that means we understand that it is dangerous. We understand the limits of what a human can handle. And we're experienced enough as a spacefaring nation now to be able to have some protection for humans out there. So the answer is yes, I would be willing to, and I think a lot of people would. What we can discover, the experience of flying in space, far outweigh, for me personally, the risk. That's a decision every astronaut would have to make. But yes, I would love to fly deeper into space if I had the chance.
Thank you, Dr. Marshburn, and good luck with the rest of your mission.
Thank you so much. It's great to talk to you. Hello to everyone down there. It's an incredible gathering you've got there. And, I feel like I'm talking to the future flight controllers and flight directors and astronauts and engineers. That's going to make life better for all of us. So thank you very much for having me with you.
Station, this is Houston ACR. Thank you. That concludes the event.